Okay, welcome back, class. This is Photocell class. Yes, we do use the Basics V3 Intro to Electronics, and we are on Lab 7, so page 22 and 23 is where we'll be turning. And I just held up the little photocell so you could see that that's what we're going to be talking about, our introduction to photocells. So flip on over there to page 22 and 23. Intro to photocells. I'm going to tell you just a little bit about photocells as you look at this one on my little thing. Pretty cool. There's photocell. Okay. A photocell is a type of resistor that uses light to control the resistance within a circuit. So we'll notice as we do our lab, we'll put our finger over it and it's going to take away the light and you'll see that it acts as a resistor. I'll read that one more time. A photocell is a type of resistor that uses light to control the resistance within a circuit. So I have an example using a night light. And I have this hooked up to just an electrical cord so that we could use it and I could video it. Okay, so a night light is an example of having a photocell. Okay, so let me slide our book over. And it's already has its current flow into it, but what is on in this room? A light. So in order to create darkness, I'm going to use this cover right here. So I'm going to take this light. Oh, look, I just put my finger over it. And I'm going to put it in the dark and notice it works. Okay? But now let's expose this same thing to light. Did you see it turn off? Let's try it again because I didn't move my phone. Darkness, light. Darkness, light. And it really doesn't even take that much. It just takes a little bit of light on that photocell and it's off. Okay? So I wanted to use that as an example of what a photocell does. All right, so it responds to the change in light to achieve a desired effect. When light is not needed, a photocell stays off to conserve electricity. So we can look back at that night light. It's not on, is it? There's light present, so it's not on. But tonight when the lights goes out, it will be back on. So it's going to conserve energy by doing that. I'll read that one more time. When light is not needed, a photocell stays off to conserve electricity. If you have ever made food, here's another example. If you've ever made food, maybe say for instance a cake, you take different ingredients, flour, milk, eggs, butter, whatever you're putting in your cake, and you mix it all together, but it took different ingredients to make that. Well, electronics are very much like making food. If you change the components, and remember this is our components box or our parts box, you can mix up different components, electrical components. I'll open it up to make it a little bit brighter color. If you mix those up, you can make a complete circuit, but you can also make a different circuit by different components that you use. Changing the components to similar components can provide the same outcome. So even though this photocell is not a resistor, we can actually use it as a resistor because it can provide resistance, but our resistance will be due to the light amount. So we'd have to keep that in mind in a circuit, okay, when building the circuit. All right, so let's jump right into Lab 7. Lab 7, what you're going to need is you're going to need a photocell, you're going to need an LED, going to need a wire, going to need one wire, battery snaps, and a circuit board. And of course, you're going to need your 9-volt battery, but we're not going to do that until I tell you, okay? Because we don't want to not have the resistance in the right place and burn out our LEDs, okay? All right, after you can pause the video right now while you get all of these things that are on your screen. And just pause the video. And then when you come back, we'll start putting it together. Okay, so we're ready to connect this lab. So the first thing you're going to need is your photocell. And a photocell will be in 21A and 22A. And so I'm looking at this photocell and I'm saying, do I need to be concerned? Does it have polarity? Well, does one of them look longer than the other? No. So 21A and 22A. 21A and 22A. And then I'm just going to push down on it and make sure it's a complete circuit. Remember, when I'm building, I want to keep things from touching. I want to make things look neat so I can find my problem if I do have a problem and it doesn't work. Hopefully I won't. I'm going to make sure it connects because this is a solderless circuit board. So remember, I'm not soldering anything together. So I want to make sure there's full contact. So I push down. Okay. My next is my LED. So I pick up my LED. I look at it and I say, oh, wait, what do I see? I see polarity, right? Because, let me put my finger up there. Can you see it better that way? Maybe not. Let's see if you can see it better. Yeah, you can see it better that way on the yellow. So can you see that? All right, so which one is my positive and which one's my negative? Or which one's my anoid and which one's my cathode? Okay, so my anoid is the longer one. That is correct. It's my positive. So my anoid goes in 21J. So 21J. And my cathode goes in 22J. So they're right beside each other. 21J is my anoid and 22J is my cathode. Then I'm going to grab my wire. It's going to go in 21E and 21F. 21E. Make sure I get good contact. And 21F. 21E and 21F. 21E and 21F. All right. If I'm going too fast, just pause the video, okay? And when you get it, then just unpause it and we'll go right back to working. Okay. And then I need my 9-volt battery snaps, and we're going to be in 21E. No, sorry, 22E and 22F. And my positive will be 22E. So let's find 22E. It's going to be my positive, which is my red battery snap line. And my 22F will be my negative, which is my black. 22F. Which is my black. Okay. So I'm going to make sure that I've got good contact with them. I'm going to recontact my wire. Make sure my 21 and 22, my LED, and then my photo wire is. I'm going to bend these so it'll be a little bit easier. And there we go. Okay. All right. So I made sure everything was good. Made sure all my wires were good. So now I'm going to contact them and attach my battery. There's my battery snaps. There's my battery. And yay, my light comes on. Okay, so it works. All right. Here's the good part. Here's the fun part, I should say. Did your LED light up? And your answer should be yes. If for any reason it didn't, call troubleshooting. Undo your battery right here. Just undo it, pop it off, and go through and check all your wires. And check everything, just like I did in the previous lesson, okay? But it did come on. So now here's the fun part. So yes, my LED did come on, but now it says to cover the photocell. So I come down here and I put my finger on the photocell. What happened to my light? It dims greatly, doesn't it? I hope you said that. See the difference? It's kind of fun. What if I only cover it part of the way, but it can still get light? It pretty much took it, didn't it? Yeah, it's pretty small. Yeah, so you can play with that and have fun with it. So what happened? It dimmed it. As I cover it and the less light gets in, then the light dims. How much light greatly impacts the brightness of the LED. And yes, we found that to be very true. A photocell is a version of a resistor, and the brightness of light impacts the LED. So you can just play around with this, covering it up, uncovering it, realizing that when you cover up your photocell, it's acting as a resistor, because it's resisting. This becomes resistant because it's not getting light. It's resisting the amount of value that the LED would get. Okay? Well, I hope you enjoyed this. Happy learning. Make sure you subscribe so you'll get more videos.